All right, so we have one last way of looking at inverses, and that is how are inverses showing up in word problems. So we have this example 39. The head circumference C of a child is related to the height H of the child. Both of those are measured in inches. Through the function, H of C is equal to 2.15 C minus 10.53. So our first step here, it says express the head circumference C as a function of height H. So anytime you see a math problem that says express something as a function of something else, that means you're solving for this first thing. Okay, so we're going to take H is equal to 2.15 C minus 10.53. And what we're going to do is we're going to solve for C. So in other words, we're finding a formula for our inverse function. We're finding H inverse of C. So I'm going to add that 10.53 to both sides. I get H plus 10.53 is equal to 2.15 C. If I divide both sides by this 2.15, I get C is H plus 10.53 divided by 2.15. Okay, and then we need an interpretation. So our interpretation always starts with whatever this isolated variable is. So I have head circumference is based on height, or is a function of height, or something along those lines. Okay, so this formula allows us to find the head circumference if we know what the height is. All right, so predict the head circumference of a child who is 26 inches tall. So we have the height, and we need to find C, so we'll use this formula here. C of 26 is equal to 26 plus 10.53 over 2.15. And if you number crunch that, you'll get that the child has a head circumference of about 17 inches. If you're thinking to yourself, goodness, I might have done something wrong, 17 inches doesn't seem that big. I thought the same thing. So I went back and looked at what the interpretation is of what we just did. So the interpretation of words in a context of this problem is a 26-inch tall child. So essentially we're talking about a baby or a very small toddler, has a head circumference of 17 inches. Okay, so when you think about this being a baby, this head circumference suddenly makes a lot more sense here. Okay, now one of the nice things about having found this inverse function is now if I asked you to predict the head circumference of a child who's 40 inches tall or 55 inches tall or whatever, magical number I pull out of my hat, you can always just plug this into this equation. So if you don't find this equation, you have to solve for each one on its own each time, as opposed to once you've found this function, you can plug in any number that anyone gives you. So that's kind of the nice thing about finding our inverse function. All right, so 40 and 41, I want you to try these on your own, but let's talk about them really quick before you pause the video. So 40 has the volume of a sphere, which is 4/3 pi r cubed. So the first thing you're going to do is find that inverse function, which means you're going to solve for r, and then interpret it in context of the problem. 41, there's no formula for your function. It's just v is equal to f of t, so relating the speed and time of a moving car. But in 41, what you're going to do is you're just going to give the interpretation in context of what that inverse function will look like, and then what are the units it's measured in. All right, so go ahead and pause the video, and we'll be back one last time to take a look at those answers. Okay, so number 40, I have v is equal to 4 pi over 3 r cubed. I'm going to divide both sides by this 4 pi over 3. So wherever when we divide fractions, we're going to multiply by the reciprocal. So we're going to turn it over and multiply. That gives me 3v over 4 pi is equal to r cubed. And then to get r by itself, I will take each side to the 1/3 power. So that gives me r is equal to 3v over 4 pi to the 1/3. Right, and then an interpretation here. So starting with this isolated variable, the radius of the sphere based on the volume. So if someone gives you the volume, you can drop it in there and find the radius. So that would be our interpretation. So for 41, we have v is equal to f of t. So we have the speed in kilometers per hour of an accelerating car t seconds after starting. So I want to take a look at the notation here because I'd like to tie in that composition of inverse functions that we looked at before. So if I take f inverse of both sides, which I can do because that is an operator, so that is allowed. I have f inverse of f of t. Okay, so f inverse of f, that's that composition thing. So it just gives me my input back. So f inverse of v is equal to t. So our interpretation here is that this inverse function is going to tell us how long the car has been accelerating based on the speed. Okay, so based on v, this velocity. And our units here are going to be in seconds. All right, so hopefully that gives you some insight into how to interpret or use inverse functions in a word problem. And good luck with the homework. If you have questions, please reach out, send me an email, let me know. I'm happy to give you a hand with it.